Alright guys, so today we're looking at standard 30, which is the law of cosines. The law of cosines is going to help us out with triangles that look like this. So we're going to label our triangles angles A, B, C. Notice we're using capital letters. And then the side opposite angle A is going to be lowercase a, opposite B is lowercase b, and opposite C is lowercase c. So that's a pretty important detail that we're going to have to remember. The law of cosines has three different versions, and it looks a lot like the Pythagorean theorem. So there's the Pythagorean theorem, c squared equals a squared plus b squared, but then we have this added part on here. Okay, so that's lowercase c, that's for the side, and then this is angle C right there. And so the other versions are basically just switching the letters around, so this is true for all the combinations. So notice, like, if side C is here on this end, angle C is on the far end, and then in the middle there we've got A and B, and then over here we've got A and B. So it's got a little bit of symmetry to help you remember it. So if I start with A squared over here, I know I'm going to have cosine of A on the far side there. And so this would be the other two sides, b squared plus c squared. And then we're going to have a minus 2bc. All of this right here is multiplication that's happening in between those things. And then so we have b squared equals a squared plus c squared minus 2ac cosine angle b. This works for when you know all three sides, or if you know side angle side. When we take a look at another law called law of sines, that's not going to work for these situations, but it will work for some other situations. So you might remember these from geometry. So here's what we mean by that. If we look at number 1 here, so we're going to draw our triangle. And it doesn't matter what order you put them in, so if I put angle A over here, it just means that side A has to be over there. And then this could be B and C, and so C is 18, that's got to be 18, and this has to be 11, and then our angle A is 47 degrees. So notice that we have a side, the angle in between, and a side. So this is a side angle side example. If we look at the next one, so that would be 5, 12, and 8. This is the side, side, side example. So law of cosines is going to work here. We might not look at any examples where it doesn't work today, but we'll probably look at that in next class when I'm back. So let's do number 1. We need to solve for the missing side first. And so we're going to set up our equation here that says a squared equals, and we're going to do this version. And now I'm just going to plug in those values that I have. So a squared equals 11 squared plus 18 squared minus 2 times 11 times 18 times cosine of 47. Now this is all like ready to go into the calculator. We're just going to go ahead and type that in just like it is. So first I'm going to make sure I'm in degree mode, and then I've got 11 squared plus 18 squared minus 2 parentheses 11 parentheses 18 cosine 47, and then I just hit enter. So that equals a squared, so I need to take the square root of that. And that's A. And let's just say 3 decimals. Okay. So, we found A. Now we need to find our two missing angles, angle B and angle C. And so in order to do that, we're going to use one of these other versions of the law of cosines here that has angle C or angle B in it. And this one's going to get a little more complicated. So one thing we're going to do is take this number and we're going to store it in the calculator so that we're not using a rounded number, because we're going to have to use this value. So we press this little button here that says STO with the arrow. We press that. You see on the screen it's got the answer with a little arrow there. And then I'm going to type the letter A. I'm typing A because it's side A. So we go alpha A, hit enter. Now anytime I type A in the calculator, it's going to use that number. You can see you can do stuff with that letter A. So if I'm going to solve for angle B first, let's say, I want to use the version that has cosine of B in it. So that's B squared equals A squared plus C squared minus 2AC cosine B. I'm going to plug my values back into that. So instead of A squared, I'm just going to remember to use the letter in the calculator. C is 18, okay, cosine B. So now I've got to do a little solving here to get B by itself. Actually, it's actually quite a bit of algebra that we have to do. So first, I need to subtract A squared and 18 squared from both sides. Then, since it's all this stuff times cosine B, wow, it's so blurry, why can't I fix that? There we go. I need to divide by -2 times A times 18. So that's going to cause that to cancel out on this side here. And then, obviously we're going to do number 2 on the back, or on a separate sheet of paper. To get B by itself, what I'm going to do is take the cosine inverse of both sides. And so notice I've solved it all on paper first, and now I'm going to take this and type it into the calculator. I like to do it all in one step because it's easier to check. So it's going to look like this. Cosine inverse, I'm going to use parentheses for the top part of this fraction. If you've got a newer calculator, you can just write this as a fraction. It's a lot easier. So 11 squared minus A squared minus 18 squared. Put that in there. And then close the parentheses for the top. And then divide it by some more parentheses for the bottom. -2 times A times 18. And the answer that pops out should be something that is realistic for an angle in a triangle. So like 37 degrees is realistic. We'll round that to 3 decimals. And that goes back up here. So that's 37.464 degrees. Okay. Now there's 2 ways that we could find the missing angle, angle C. One way is we could just do 180 minus the answer that we just got, minus 47, because we know that triangles add to 180. So we're expecting that this angle equals 95.536 degrees. Or we could do this same process here that we just did for angle B. And usually actually I prefer doing this because just in case we got this wrong, we would want to be able to do this to double check and make sure that we get the same answer for angle C. So for angle C, that process would look very similar. We would have C squared equals A squared plus B squared. We would use this version here that's got cosine of C in it. C is 18, A is stored in the calculator. And then we would do our solving process So first we would need to subtract a squared and 11 squared. Then this stuff here that's multiplying cosine of c, we're going to divide by that. And then that all cancels out. We're going to take the cosine inverse of both sides of the equation. So I'm ending up taking the cosine inverse of that whole left side of the equation there. And that's what's going to go in the calculator. Now what's nice here is I typed something really, really similar to that earlier. So if I want, I can just go up and edit the entry. So here I've got 18 squared minus a minus 11. So right here I'm just going to switch 11 and 18. I'm going to change that to 18, change that to 11, and then down here on the bottom it's negative 2 times a times 11. So I'll just change that. And look, that gives me the angle that we were expecting to get. So it's actually not a ton of work to check your answer in the calculator, to just do the whole solving process again. Especially once you get the hang of it, it's really just switching some numbers in your calculator. Okay, so we'll look at number 2 here. I don't have to use my other sheet of paper. So in this triangle, we don't have any angles. We just have all 3 sides. So our process is going to be really, really similar to what we just did. We can start with any side. It doesn't matter which one at all. So we can start with A, or that's not A, that's C. We can start with angle A, and so we would want to start with a version that has A squared on one side. And I'm just going to substitute those numbers in. And again, like, it's going to be the same process here. So I'm going to subtract 12 squared and 8 squared from both sides. I'm going to divide by all this stuff that I'm multiplying right here so that it cancels. And then once I have that, oops, not negative 5. I'm going to take the cosine inverse of both sides. And then that's going to go into the calculator. So very, very similar. I mean, it's the exact same process. It's not even similar. It's the exact same. Notice, I could use the calculator to figure out what that number is, or that number right there, but I really prefer to just enter it in all as one step, because again, it's really easy to look back and see what I've typed into the calculator and make sure that I've typed it in correctly. Like, your calculator has the amazing ability to just one-shot this problem, so why not just let it do that? And so it's telling me that angle is 17.612 degrees. Now check this out. So sometimes you might forget either a parentheses or a negative sign or something like that, and you might type it wrong. 9 times out of 10, if you do that, it's going to give you a domain error, because basically what you're typing into cosine inverse is too big to be an angle. So this is the advantage. I could go back and look and say, okay, there's the top in parentheses. Oh man, I forgot a parentheses on the bottom there. Let me put that in. So it's self-checking a little bit. Notice when we do this that 17.612 is pretty small for an angle, but it's also opposite the smallest side. And you remember from geometry that that's what we're supposed to see, largest side opposite from longest side opposite largest angle, shortest side opposite smallest angle. So you can just check your answers to make sure they're reasonable. Okay, so now we just do the same thing again. We don't have to store the variables because we're not going to use this angle A. We just need to do the same process for B and C, and you can pick whichever one you want to do first. And if you remember the shortcut, it's going to be basically just changing some numbers around in the calculator. So if I wanted to solve for angle B next, I would put this version here. Start with that. And once you're really good at this, of course, you won't have to write out this every time, but we'll just go ahead and do that for right now. And same process here. Subtract these two, divide by this, take the cosine inverse in that order. So what I'm going to be left with is cosine inverse 12 squared minus 5 squared minus 8 squared over negative 2 times 8 times 5, all inside the cosine inverse. If I have an older calculator, I need parentheses here. Newer calculator, you can just type alpha y equals to get the fraction, and then you press enter. You can just put the fraction in there. It's pretty nice. I've got an old calculator right here. So again, notice what's happening here is the 12 and the 5 are switched from what I had. So if I go back here, I can just go 12 squared minus 5 squared, and then change this guy to a 5. And it's telling me that angle is 133.433. degrees. And again, that's opposite the 12. So that's by far the biggest angle so far, and this is also by far the biggest side. So that's pretty good. We're expecting to see that. Okay, so again, I could subtract everything from 180, or I can just do the law of cosines again. And now I'm starting to think ahead and say, okay, well, if angle C is what I'm looking for, then we're going to have the version with C squared equals A squared plus B squared minus 2AB cosine C. So notice B and C are switching here. And so maybe I can just switch B and C in the calculator and save myself some time. So if you want to give that a try, go ahead and do that, but I'll go ahead and set it up here. So this would be, where's C squared? 8 squared equals 5 squared plus 12 squared minus 2 times 5 times 12 cosine C. And then again, subtracting those, dividing by those, taking the cosine inverse. So I see, okay, what's switching? It's the 12 and the 8 are switching from what I had before. And so I see my angle there is 28.955. And something I can do is I can check all those to make sure they add up to 180. Could be a good way to check and see if I did it right. They should. Sometimes they won't exactly add to 180. They might be like just a little decimal point off. And that's okay. That's because your calculator is rounding. That's because we're rounding like 179.997. That's okay that those don't add to 180. Each of these was rounded correctly based on our result from the law of cosines. If we added the full decimals together, they would equal 180. Okay, so for our last example here, go ahead and pause the video, you guys, and do this one on your own, and then once you're finished, you can unpause the video and check and see, and I'll go over it. Okay, so here we go. A, B, C, that's going to be 30, 24, 30, this is 30 degrees. So we have to start with side C, don't forget. So C squared equals 30 squared plus 24 squared minus 2 times 30 times 24 cosine of 30. Now we should know that cosine 30 is root 3 over 2, but again, I'm going to let the calculator do this. 30 squared plus 24 squared minus 2 times 30 times 24 cosine 30. And then, so that's C squared, so I have to take the square root of the answer, and that is 15.130. Okay, I'm going to store that in the calculator. I'm going to store it as C. Now I'm going to solve for angle B. So I'm going to get B squared equals A squared plus C squared minus 2AC cosine B. So that's 30 squared plus, equals 24 squared plus A squared. Oh, not A squared, sorry, C squared. Minus 2 times 24 times C. So that'll be the cosine inverse of 30 squared minus 24 squared minus C squared over 2 times 24 times, sorry, negative 2 times C. So that's what's going to go in the calculator here. Parentheses 30 squared minus 24 squared minus alpha C squared, close the parentheses, divided by negative 2 times 24 times alpha C. So for angle B, we're getting 97.522 degrees. And then as I set this up to find angle A, there's side A. 2 times 30 times C cosine A. So I'm going to be typing in the cosine inverse, 24 squared minus 30 squared minus C squared, negative 2 times 30 times C. And so again, in the calculator, I'm just going to be switching 24 and 30. I would definitely, you would always want to show your work, because, oh man, I gotta go way back. Dang it, there it was. Notice I'm always showing my work over here before I start typing in the calculator, changing numbers. Like, I just want to make sure. What I'm trying to do is increase my efficiency while at the same time making sure it's really easy for me to check and see if I've made a mistake. If I got an error of some kind, I would want to be able to compare it to this. If my angles didn't add up to 180, I would want to be able to go back and see what I did. So the more work that we end up doing in the calculator, I would say the easier it is to make a mistake and not realize it or not be able to find it, just because so much of what is happening here. Again, that's why I like to make it one step. Like, it's all there, one step. I can see exactly what I typed. And this is going to be a big sticking point. Like, I'm going to yell at you if you're doing it a different way. So, like, what I mean by that is I'll definitely see people start this problem off and they'll go 30 squared plus 24 squared minus, they'll go like, I don't know even how they do it. And then they'll do like 2 times 30 times 24 times cosine 30. And then they'll say 1476 minus that answer. And then they'll do square root of the answer. And the problem with this is, like, look, I got the right answer for C, but look how many steps are in my calculator. And what if I made a mistake, like, and then now it's up here and I can't get to it? Or the newer calculators you can scroll up, but still, don't do this. Don't do this. Just write it out and just type that in to the calculator, all one step like we did, and let the calculator do it. I'm telling you, it's going to save you time in the long run. I am going to yell at you if you don't do this. I'm going to make fun of you for doing math like a simpleton. So if you wanted to even shortcut it, that first step, I could put all of it in a square root and do it all in one step there. So there you go. That's the law of cosines. Pretty straightforward. We'll talk about law of sines in the next class. That's it.